Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about some questions and their answer from solid state chapter. So first question is, why are solid rigid? You know, the constituent particle in solid have fixed positions and can oscillate about their mean positions, hence they are rigid. The next question is, why do solids have definite volume? The answer is, solids keep their volume because of rigidity in their structure. The interparticles forces are very strong. Moreover, the interparticles spaces are very few and small as well. As a result, their volume cannot change by applying pressure. Now, third question is, classify the following as amorphous or crystalline solid: polyurethane, naphthalene, benzoic acid, Teflon, potassium nitrate, cellophane, polyvinyl chloride, and fiberglass copper. So crystalline solid, you know, benzoic acid, potassium nitrate, copper, amorphous solid, polyurethane, Teflon, cellophane, polyvinyl chloride, and fiberglass. Now, the next question is, why is glass considered as a supercooled liquid? Glass is considered to be supercooled liquid because it shows some of the characteristic of liquids, though it is amorphous solid. For example, it is slightly thicker at bottom. This can be possible only if it has flown like liquid, though very slow. So, next question is, refractive index of solid is observed to have the same value along all directions. Comment on the nature of this solid. Would it show cleavage property? As the solid has same value of refractive index along all directions, it is isotropic in nature and hence amorphous. Being amorphous solid, it will not show a clean cleavage, and when cut, it will break into pieces with irregular surfaces. My friend, next question is, classify the following solid in different categories based on the nature of the intermolecular forces: sodium sulfate, copper, benzene, urea, ammonia, water, zinc sulfide, diamond, rubidium, argon, silicon carbide. So, ionic, metallic, molecular, hydrogen bonded, ionic, covalent, metallic, molecular, covalent network. So you can classify like that. The next question is, solid A is a very hard electrical insulator in solid as well as in molten state and melts at extremely high temperature. What type of solid it is? So answer is, it is a covalent or network solid. The next question is, why are ionic solid conducting in the molten state and not in the solid state? In the ionic solid, the electrical conductivity is due to the movement of the ions. Since the ionic mobility is negligible in the solid state, these are non-conducting in this state. Upon melting, the ions present acquire some mobility. Therefore, the ionic solid become conductive. Now friends, the next question is, what type of solid are electrical conductors? Malleable and ductile. So metallic solid. Next question is, give the significance of a lattice point. You know, the lattice point denotes the position of a particular constituent. In the crystal lattice, it may be atom, ion or molecule. The arrangement of lattice point in a space is responsible for the shape of a particular crystalline solid. The next question is, name the parameter that characterize unit cell. A unit cell is characterized by the following parameter: the dimensions of unit cell along three edges A, B, C, an angle between the edges A between B and C, alpha, beta between A and C, and gamma between A and B. Now the next question is, distinguish between hexagonal and monoclinic unit cell. face centered and end centered unit cell? Answer is, in a hexagonal unit cell, A is equal to B is not equal to C, alpha is equal to beta is equal to 90 degree and gamma is equal to 120 degree. In a monoclinic unit cell, alpha is not equal to beta is not equal to C, and alpha is equal to gamma is equal to 90 degree and beta is not equal to 90 degree. In a face-centered unit cell, constituent particles are located at all the corners as well as at the center of all the faces. Now friends, the next question is the same parts. In a face-centered unit cell, constituent particles are located at all the corners as well as the center of all the faces. In center, unit cell constituent particles are located at all the corners as well as the center of the two opposite faces. You can see the face-centered unit cell. Now the next question is, explain how many portions of an atom located at corner and body center of a cubic unit cell is a part of its neighboring unit cell. So answer is, an atom and the corner is shared by 8 adjacent unit cell. Hence portion of the atom at the corner that belong to one unit cell 1 by 8. So an atom at the body center is not shared by any other unit cell, hence it belongs to fully 2 unit cell. The next question is, what is the two-dimensional coordination number of molecules in a square closed pack layer? In the two-dimensional square closed pack layer, a particular molecule is in contact with the 4 molecules. Hence the coordination number of molecules is 4. The next question is, a compound form hexagonal closed pack structure. What is the total number of voids in 0.5 mole of it? How many of these are tetrahedral? Number of atom in closed packing 0.5 mole is equal to 0.5 into Avogadro's number. Then number of octahedral void is equal to number of atom in packing. So number of tetrahedral void 2 into number of atom in packing. So 2 into, then you will get again 2.02223. So total number of void 3.00011 into 10 to the power 23 plus 6.022 into 10 to the power 23. So 9.033 into 10 to the power 23. Now the next question is, a compound is formed by 2 molecules M and N. The element N forms CCP and atom of the element M occupy 1 by 3 of tetrahedral void. What is the formula of compound? So let us suppose that the number of atoms of N present in CCP is equal to X. Since 1 by 3rd of tetrahedral void are occupied by the atom of M, therefore the number of tetrahedral void occupied is equal to 2x divided by 3. The ratio of atom N and M in the compound x is to 2x divided by 3 is equal to 3 is to 2. So the formula of compound N3M2 or M2N3. The next question is, which of the following lattice has the highest packing efficiency? Simple cubic, body center cubic and hexagonal closed packing. So packing efficiency of simple cubic 52.4%, BCC 68%, SCP 74%. So SCP lattice has the highest packing efficiency. Now friends, next question is, an element with molar mass 2 into 7 into 10 power minus 2 kg per mole forms a cubic unit cell with edge length 405 pm. If its density is this, what is the nature of cubic unit cell? So friends, you can apply this formula. We know that rho is equal to z into m a cube into n naught into 10 power minus 30. So you have to calculate a z. So just rho is already given, a site is given, Avogadro number 10 to the power minus 3 is the number, and divide with the m. So edge unit cell A is equal to this one, molar mass of unit cell, this density of unit cell given, Avogadro number then after putting all values you will get approx 4. So since there are 4 atoms per unit cell, cubic unit cell must be face centered or cubic close packed. The next question is, what type of defect can rise when solid is heated? Which physical properties is affected by it, and in that way, in what way? So the answer is, when a solid is heated, vacancy defect is produced in the crystal. On heating, some atom or ion leaves the lattice site completely. Lattice site become vacant. As a result of the defect, density of the substances decreases. Now next question is, what types of stoichiometry defect are shown by zinc sulfide and silver bromide? You know, zinc sulfide crystal may show Frankel defect since the cationic size is smaller as compared to anionic size. Silver bromide crystals may show both Frankel and Scotty defect. The next question is, explain how vacancies are introduced in an anionic solid when cation of the higher valence is added as a impurity in it. So let us take an example: sodium chloride doped with strontium chloride. Impurity: when strontium chloride is added to sodium chloride solid as impurity, 2 sodium ion will be replaced and one of their sites will be occupied by strontium, while the other will remain vacant. Thus we can say that when a cation of higher valence is added as an impurity to an anionic solid, 2 or more cation of lower valency are replaced by a cation of higher valency to maintain electrical neutralities. Hence, some cationic vacancies are created. Now the next question is, ionic solid which have the ionic vacancy due to metal excess defect develop color. Explain with the help of suitable example. You know, let us take an example of sodium chloride. When sodium chloride crystal is heated in presence of sodium vapor, some chloride ion leave their lattice site to combine with sodium to form sodium chloride. So like this you can, then you see this electron lost by sodium to form Na plus, and then diffuse into the crystal to occupy the anion vacancy, and these sites are called F center, and these electrons absorb energy from visible light, get excited to higher energy level. When they fall back to ground state, they impart a yellow color to sodium chloride crystal. Now friend, the last 2 questions. This question is, a group 14 element is to be converted into N-type semiconductor by doping it with suitable impurity. To which group should this impurity belong? Impurity from group 15 should be added to get N-type semiconductor. So what type of substances would make better permanent magnet? Ferromagnetic or ferrimagnetic? Justify your answer. You know, the ferromagnetic substances make better permanent magnet. This is because when placed in magnetic field, their domains get oriented in the directions of the magnetic field and a strong magnetic field is produced, and this ordering of domain persists even when external magnetic field is removed. Hence the ferromagnetic substance become a permanent magnet. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.